Hi everyone, welcome to lesson 1 of the quadratic function unit. In this lesson we're going to talk first off about just what is a quadratic equation. So quadratic equation means any equation with a degree of 2, and degree refers to the exponent. So if I were to insert just the easiest, most basic quadratic equation there is, it would be f of x equals x squared. That's as simple as it gets. That is like the hamburger with nothing on it. It's called the parent function. Now you can have all sorts of things in addition to that that are also quadratic equations. You may have a coefficient on the x squared term that's not 1, like 2x squared. And you may even have 2x squared plus another x term. I don't know, I'll just make some stuff up here. Plus 3x. And you can have a constant term as well, plus 1. So there can be infinite amounts of different quadratic equations. You might even have just a negative 4x squared. I mean, that's also a quadratic. So what makes a quadratic equation is the degree, which again, the degree refers to the exponents, and so the highest, the biggest exponent in that function is going to be 2, which means it's a quadratic. So they're all 2. So they all have degree 2, and the standard form, just the generic form of any quadratic equation, would be f of x equals, we use a for any number, coefficient of the x squared term. So it'd be ax squared plus the coefficient on the x term is b, plus bx, and then we use c for the constant, which has no x. So this is what we call standard form of a quadratic equation. So this is standard. Okay. Now, what does a quadratic equation look like if you graph it? You may have heard of this, but all quadratic equations, when you graph them, are called parabolas. And they look like this. It's kind of like a U. Or they can also be upside down U. And some are skinny, some are wide. They come in all shapes and sizes, but actually the same shapes, just wider or skinnier, and they move around on the XY axis. But they all have a special point on them, which is called the vertex. And that is where the function switches from going decreasing, 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 and it hits the very bottom or top, depending if you're here or here, and then switches over to increasing or decreasing, whichever one you were doing first. So this one's decreasing, 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 then it switches over at the vertex, and then it starts to increase. So this special point on every parabola is called the vertex. And it's either a maximum or a minimum depending on if it opens up or down. So since this one is a parabola that opens up, so this one is, we say upward or opens upward, its vertex then is a minimum. If it opens downward, like this one, so opening downward kind of is the upside down U. If it opens downward, then the vertex is a maximum. So there's a little bit about what the parabolas look like as far as the graph goes. So there's a vertex that's a min, there's a vertex that's a maximum. And another special quality that all parabolas have is that they are symmetrical, which means if you draw a vertical line going through that vertex, they are exactly symmetrical. If you folded them on this line, they would match up on themselves perfectly. And this yellow line here has a special name for it. We call that the axis of symmetry. So when you're making a sketch of a graph, it's helpful to find that vertex so you can determine your axis of symmetry. Okay, so every parabola has a vertex, an axis of symmetry, and it either opens upward or downward. So a little bit about the upward or downward. If this a value right here, so this a value, if it is positive, that means that it opens upward. So if a is positive, that means it opens upward. And you may guess then that if it's negative, what do you think happens? It opens downward. So a, the leading coefficient of the x squared term, if it's positive, it opens up. If it's negative, it opens down. Let's take a look at a few examples here. Okay, here's a function. Here's a function, f of x equals x squared minus 4x plus 3. So let's first identify our a, b, and c. Again, a is the coefficient of x squared, and if there's nothing there, then technically there would be an invisible 1 there. So a in this case is going to be 1. Oops. A in this case will be 1 because of this invisible 1. If there's nothing there, it's 1. B is a coefficient of x, and if it's minus, that's negative, so b is going to be negative 4. And c is the constant term, which is positive 3. So there's my a, b, and c. Is a positive or negative? Well, a is positive 1, so that means the graph opens upward. And the axis of symmetry. The axis of symmetry, as you have found from your reading, is equal to the opposite of b over 2a. So the opposite, or negative b, divided by 2a will give you the value of your axis of symmetry, which is just an x value, and it's a vertical line. A vertical line is always x equals some number. So my b value is negative 4, so this is going to be, if it's the opposite of negative 4, that's positive 4, all over 2 times a, and a is 1, so that's 2 times 1, which is 2. So my axis of symmetry is the vertical line x equals 2. So I can go over to my graph, and I know that my graph is going to be symmetrical about this line, vertical line, which is the axis of symmetry, x equals 2. I also know that the vertex is on that axis of symmetry. So somewhere on this axis is going to lie my vertex. So to find exactly what point it's at, I need to evaluate the function when x is 2. So I'm going to take x equals 2, and I'm going to plug it in, substitute in for x into my function, and evaluate. which is what this fancy looking symbol means here. This f parenthesis negative b over 2a, that means evaluate the function at the value for x opposite of b over 2a, which we found that to be 2. So really we're finding the function evaluated at x equals 2. So that's going to be 2 squared minus 4 times 2 plus 3. Okay, exponents first. This is 4 minus 8 plus 3. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So that tells me that my f of 2, is equal to negative 1. So that means my vertex is at the point 2, comma, negative 1. So where is that? Of course, it's on this dotted line. So this is going to be on the dotted line because x is 2 and my y value is negative 1. So here is my vertex right here. Okay? And I know it opens up. So all I need is one other point to get a good sketch. And the one other point that I need is the y-intercept. And the y-intercept is the c in your standard form function, your constant term that's always your y-intercept. Because your y-intercept is when x equals 0. So at your y-intercept, where x equals 0, is going to be that's your y-intercept. So whatever that c value is, that's your y-int. So in this case, this function, my y-intercept is 3. So that means that other point on the function, on that graph, is my y-intercept at 3. Okay? If this is my axis of symmetry, then I know that on the other side of the axis is going to be a point exactly the same at 3, which is 2 units away from the axis on both sides. So now I can go ahead and just make a nice sketch of my parabola. It opens up, it goes through these 2 points, and it has a vertex here of 2, negative 1. So there's your first quadratic function. Okay, here's a couple more examples, and we'll take a look at 2 more. I pulled these from one of the worksheets here, so we'll do the same exact thing with these functions. First off, is it in standard form? And that means x squared term, x term, constant term. It is. Okay. Does it open up or down? And that depends on my a value. So here's my a is 3, my b is 2, my c is 1. So if my a is 3, that's positive, so it opens up. Okay, I don't like the way that looks. So it opens upward. Alright, what about my axis of symmetry? My axis of symmetry, remember, is your opposite of b over 2a. So that's going to be how we find our vertex as well. So the opposite of b over 2a, okay, my b is 2 in this case, so the opposite of b is going to be negative 2 over 2 times a. A is 3. Okay, so that means 2 times 3 is 6, so this is going to be a fraction. So negative 2 6. Alright, that's the same as negative 1/3 if I reduce it. So my axis of symmetry is going to go right along here about at negative 1/3. So now what is the y value, or the f of x value, at negative 1/3? What is f of negative 1/3? Let's put that in our function. If we have 3 times negative 1/3 squared, plus 2 times 1/3, negative 1/3, excuse me, plus 1. Okay, negative 1/3 squared is going to be positive 1/9. So this is going to be 3 times 1/9, which is 3/9, plus 2 times negative 1/3, that's going to be negative 2/3, plus 1. Okay, well, I'm going to erase this 3/9 and I'm going to change it to its lowest term. So 3/9 is the same as 1/3, so I'm going to click that, erase it, and I'm going to make it 1/3 so I have common denominators. So that really was 1/3 plus a negative 2/3, which ends up being negative 1/3. And negative 1/3 plus 1 is 2/3. So my f of, bring that all the way around, my f of negative 1/3 is 2/3. That means my vertex is on this point at the value 2/3. So it's somewhere right in here. My y-intercept is 1, so it kind of crosses right here. So my y-intercept is really close to my vertex. So I can't really get a great idea of what this is going to look like as a sketch, but I know it opens up and it goes through these 2 points, and this is just a rough sketch at this point. So we're just going to make just to kind of get an idea of where it's going to be and explore some of these values. Okay, let's move over to the next one here. This one is going to open downward because it has a negative a. So that means it's going to be downward opening. Alright, my axis of symmetry, opposite of b over 2a, is going to be the opposite of negative 4, which is 4, over 2 times negative 2, which is negative 4. So this one's going to work out a little easier. My axis of symmetry is x equals negative 1. So we don't have fractions this time. So here's my axis of symmetry at the value x equals negative 1. Where is my vertex on that point? Remember, it's always on the axis of symmetry somewhere. So we're going to take negative 1 and we're going to plug it in for x to find where my y value is. So I have negative 2, and I always write this all out. Negative 2 times negative 1 squared minus 4 times negative 1 minus 2. To evaluate that, we have to do the exponent first. Do not multiply this and then square it. That's a violation of the order of operations. So square negative 1, you get positive 1, then multiply by negative 2. So we have negative 2 minus 4 times negative 1 is a negative 4. So there is a minus a negative there, which everybody knows that minus a negative is the same thing as plus a positive. So we'll just change that to plus a positive there. And then minus 2. So negative 2 plus 4 is 2, minus 2 is 0. So all that is 0. That means our intercept is right on the x-axis, negative 1, 0. I'm sorry, I said intercept, I meant vertex. So our vertex v is at the point negative 1, 0. It opens downward and it has a y-intercept up here of negative 2. So that means my y-intercept is there, which I can have another point on the other side of the axis here, and it opens downward. Now I can make a nice sketch opening downward. It's a parabola. has a vertex which is a maximum value at the point -1, 0. And that's it. That's about it. We're just getting a basic idea. What is a quadratic equation? What are some of the points on the graph, which is a parabola? And probably the most important point is this vertex. So that'll get us started. You'll do some problems on the book here, get some more practice. Remember, if you have any questions, please post them to the Module 1 question board, and I should be able to get reply to that post pretty quick. If you want to email me, you can, and I will be available after school as well. So good luck.